guys, today we are going to do section 4.2, standard form of a quadratic function. So you will be able to graph quadratic functions written in standard form. Our big idea, for any quadratic function, f of x is equal to ax squared plus bx plus c. The values of a, b, and c provide key information about its graph. So, our properties of quadratic functions in standard form. The graph of f of x is equal to ax squared plus bx plus c, where a is not equal to 0, is a parabola. So this is the standard form of a quadratic. If a is greater than 0, the parabola still opens upward. And if a is less than 0 or negative, the parabola still opens downward. Now we have the axis of symmetry as the line x is equal to negative b over 2a. The x-coordinate of the vertex then is negative b over 2a, and the y-coordinate of the vertex is the value of the function for x, negative b over 2a. So we have to plug in whatever value we get for x by getting negative b over 2a into our function to get the y value. And we have a y-intercept is equal to 0, c. So c in our standard form is the y-intercept. Graphing a function in the form y equals ax squared plus bx plus c, or in standard form, we are going to still follow the same steps. But in order to find our vertex, or our first step, we have to use x is equal to negative b over 2a. The first thing you should do then, once you have your equation in standard form, is identify your letters. So a is equal to 1, b is equal to 2, and c is equal to 3. Now plug it into x. X is equal to negative b over 2a, so negative 2 over 2 times 1, which is equal to negative 1. Now that we have negative 1, in order to find y, we're going to plug it into our equation. So y is equal to negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1 minus 2 plus 3. 1 minus 2 is negative 1 plus 3 is y is equal to 2. Now we have our vertex, negative 1, 2. I'm going to go ahead and plot that point. And I also know that this is my axis of symmetry. I need to find 2 points on the one side of my axis of symmetry, so I'm going to plug in 0, and 0 plus 0 plus 3 is equal to 3, so 0, 3 would be our next point. Then I'm going to plug in 1, so y is equal to 1 squared plus 2 times 1 plus 3. 1 plus 2 is 3 plus 3 is 6. 1, 1, 2, 3, 4, 5, 6. And I'm going to reflect. And connect with a parabola. Now we have to convert standard form into vertex form. So if we remember what vertex form is, we have y is equal to a times x minus h squared plus k. And we want to go from standard form to vertex form. So first you're going to identify a and b. A is equal to 2, and b is equal to 10. So we're going to find the x coordinate of the vertex, and we know that x is equal to negative b over 2a, which is negative 10 over 2 times 2. Negative 10 over 4, which is also equal to negative 2 and a half. We're going to substitute negative 2 and a half into our equation to find y. So y is equal to 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. If you put that in your calculator, we get negative 5.5. So we have our x value and our y value. We're going to substitute what we know into our vertex form. We know that a is equal to 2 from our standard form. We know h, which was our x coordinate, is negative 2 and a half. And we know that k, which is our y coordinate, is negative 5.5. So if I plug that all in, y is equal to 2 parentheses x. Since this originally is minus and we want it to be a negative 2.5, we're going to make it positive 2.5 squared minus 5.5. So that is my vertex form. You guys are going to go ahead and write this standard form into vertex form and then be done with section 4.2.